Good afternoon, my YouTube viewers. In this video, what we're going to do is we're going to do hypothesis testing, and we're going to do it on a practice question about bottles. And so what we're going to do is we're going to check to see if the bottles are 200 milliliters. So the null hypothesis is the mean equals 200 milliliters, and the alternate hypothesis is the mean does not equal 200 milliliters. So what we're going to do is we're going to write a program in Python to carry out this null hypothesis. So in order to write the program in Python, the first thing that we're going to have to do is we're going to have to import some libraries. So the first library that we're going to import is NumPy SNP. NumPy is a numerical library that performs numerical computations. It creates NumPy arrays, and it also creates distributions. And then we're going to import matplotlib.pyplot.splt, which is a visualization library. And lastly, we're going to import scipy.stats as stats. Now, scipy is Python's scientific library, and stats is a statistical module within scipy. So now, after we have imported our libraries, what we're going to do is we're going to define our parameters. So the population mean is 200 milliliters. The number of samples is 10. The standard deviation is 0.8. The sample mean is 199, and the alpha, which is the significance level, is 0.05. So now what we're going to do is we're going to calculate our z-score. So your z-score is your sample mean minus your population mean. So that's going to be -1 divided by the standard deviation divided by the square root of the number of samples. So the square root of the number of samples is going to be the square root of 10, so it'll be a little over 3. So the standard deviation is 0.8. So we're going to say the standard deviation divided by is 0.8. Divided by the square root of the num samples. It says it's 0.25. That's what it says. And then so the population mean, the sample mean is 199 minus the population mean of 200. So that's going to be -1. So we're going to try that. So we're going to say -4. So that's close to it. That's what we're going to say. So your z-score is your, and then after we've calculated our z-score, we're going to calculate the p-value. So the p-value equals 2 times 1 minus stats.norm CDF, the absolute value of the z-score. So stats.norm is a normal distribution, and CDF is a cumulative distribution function of the z-score. So now what we're going to do is we're going to print our z-score, and then we're going to print our p-value. And then we're going to ask the question, if the p-value is less than alpha, and alpha is 0.05, then you reject the null hypothesis. The sample mean is significantly different from the population mean. Otherwise, if the p-value is greater than alpha, you fail to reject the null hypothesis. The sample mean is not significantly different from the population mean. So, and then what we're going to do is we're going to visualize visualize the data. So we're going to generate x values for the standard normal distribution. X equals np dot line space brackets -3, 3, 1000. Y equals stats.norm.pdf x. So norm is normal distribution and PDF is it's a distribution function, a probability distribution function. And now we're going to plot the standard normal distribution. plt.plot brackets x, y, label equals standard normal distribution, color equals blue, and then we're going to shade the critical region. So z critical equals stats.norm.ppf, and ppf stands for percentage point function, brackets 1 minus alpha. So that's going to be 1 minus 0.05. So that's going to be 0.95 divided by 2. And so 0.95 divided by 2, I think is 0.475. I think that's what it is. And then now plt.fill between brackets x, 0, y, where equals brackets x is less than or equal to negative z critical, or x is greater than or equal to z underscore critical, color equals red, alpha equals 0.5, label equals critical region. So we mark the z-score on the plot. So plt.ax line brackets z-score, color equals green, line style equals dashed, line width equals 2, label equals z-score. So now we're going to add titles and labels. The title is z-test hypothesis test. The x label is z-score. The y label is probability density. And then we're going to plot the legend, and then we're going to show what we plotted. So your z-score is negative 3.95, and your p-value, and let's see, 3.95, and I sort of calculated it on my calculator, and I got a -4, so it was close. What I calculated was close to what Python calculated, because Python used more digits to the right than I did. And then, so z-score is 3.95. P-value is 0.0001. So with a p-value of 0.0001, that is less than 0.05. So you're going to reject the null hypothesis. The sample mean is significantly different from the population mean. And so you can see here we've got our standard normal distribution in blue, you've got your critical region in red, and you've got your z-score as being -395, which is less than the critical region. But what I want to check here is, because it gives you the sample mean of 199, but it says the sample mean of 199 is still significantly different from the mean, from the population mean. But that's the way it works, because we've got our population mean of 200 and a sample mean of 199, and our alpha is your significance level of 0.05. And so your sample mean is still, according to Python, is significantly different from the population mean. So although we may think, oh, well, it's only 1 milliliter difference, according to Python, Python thinks that the sample mean is significantly different from the population mean, even though it's 1 milliliter difference. So that's it. This is the diagram that we have made to show the normal distribution, the critical region, and the z-score. And so you can see that the z-score is out of bounds from the critical region. So that's it for this video. The next video is going to be another practice question, and I hope that you decide to watch it.